In this video, we're going to look into surfaces in space, which will include some that we already know. Spheres look like this. Planes look like this. Another type is called a cylindrical surface, and we'll define that directly. But also we're going to look into the three-dimensional version of conic sections. They're not called conic sections in 3D, and they don't have anything to do with cones either, but there's something similar to ellipses, for example, or ellipsoids, which are shaped like some kind of weird vitamin pill. Ellipsoidal in 3D space, etc. But those things are called quadric surfaces. So let's at least define what a cylinder is. Now, I know you're used to a cylinder being a right circular cylinder, something shaped like a can, but that's not really the definition of cylinder. That is a right circular cylinder. A cylinder, in our view, our Calc 3 view, is going to be, if C is any curve in a plane and L is any line not in a parallel plane to that curve C, then the set of all lines parallel to this line L that intersect C is called a cylinder. Now let me see if I can show that to you. Like, for example, this one's a right circular cylinder, but here's our curve C, and look at all these lines L that intersect it and are parallel to each other. Aha, now maybe you get the idea. That this is called a cylinder, and I'll grant you this one's a right circular cylinder, but there's no reason why this has to be a circle. This could have been a triangle, and then this would still be called a cylinder or a cylindrical surface. Okay, but C is called a generating curve. That's, in this case, it's a circle, and the set of parallel lines are called rulings, but I'm used to calling them generators, so I call them generators. So. And the purple lines are the generators, right? And the black circle, that's this one in here, is a generating curve in the right circular cylinder. But this curve could have been a square, it could have been a rectangle, and that thing would still be called a cylinder. So let's see if we can do one. Here's a surface, z equals x squared. So f of xy equals x squared, and look, you sort of knew what it would be, because if you only had two variables, which is not the case, but if you only had two variables, it would be, I'm trying to make it look like one, it would be a parabola, see, like that. But when we have three variables, right, then it's a parabola. Actually, these lines that you can see going across there are the generators, and the graph of the parabola y equals x squared is the generating curve, right? So the parabola is the generating curve, and these lines are the generators, and that makes our surface. Here's another one. Sketch the surface z equals cosine y. Well, before I go down there and look at it, what do you think f of xy equals cosine of y would look like? Why, of course, it would look like a wavy old cosine graph, but instead of being one dimension, would be like sort of like a plane that's wavy, sort of like looking out at the ocean, right? And here it is, right? Here it is. See the ocean waves there? I guess that doesn't look all that oceanic, but I could make it look a little more like the real thing, and I will. Okay, what I did to make it look like this, I increased its domain in x and y. Instead of from -5 to 5, I went from -10 to 10, and then I clicked on equal scale, so the z scale and the x and y are the same. So now it does look like waves in the ocean.